We hear so much about the power of large language models, but what's the real secret sauce behind them? It's not just about clever algorithms. Today, we're going to pull back the curtain on the single most critical, yet often overlooked part of building great AI, the art and science of preparing high-quality data. Right off the bat, let's get this straight. This is the golden rule of machine learning, and it is absolutely non-negotiable. Garbage in, garbage out. Why? Well, because an LLM knows nothing about the world except for what we show it. So if you feed it flawed, biased, or just plain messy data, you're literally teaching it to be flawed, biased, and messy. There are no shortcuts here. And the stakes? They couldn't be higher. The difference between bad data and good data is, well, it's the difference between a chatbot that confidently makes stuff up and a reliable professional tool that you can actually trust to deliver accurate results. One is a total liability, the other is a game changer. So let's really dive into that core principle. Garbage in, garbage out. You have to remember, these models aren't just born smart. They learn from what we feed them. The best way to think about it is that the dataset is the model's entire education. It's the textbook, the teacher, and all of its life experiences, all rolled into one. Okay, so before we can start building anything, we need to understand our materials, right? What are the fundamental building blocks of an LLM's knowledge? Let's take a closer look at the anatomy of the data itself. Just look at this. You can really see the sheer variety of food an LLM can digest. It's not just one type of information. We can train them on everything from simple instructions to really complex dialogues to super specialized legal documents or even different coding languages. This diversity is what lets us create these really expert, specialized models. Now, among all these different data types, there's one format that really reigns supreme for training: JSON. That stands for JavaScript Object Notation, and it's the king because it's incredibly clean, it's structured, and it's just super easy for machines to understand. It creates a perfect, unambiguous blueprint for the model to learn from. And this is a perfect example of just how simple and powerful that blueprint can be. See, you have a crystal clear instruction, you have the input data to work with, and then you have the ideal output. Every single one of these examples is like a mini lesson, teaching the model, hey, when you see this, do this. Now for conversational AI, the models that power things like Llama or Mistral, the format's a little different, but it follows the exact same logic. Here, each piece of the conversation is tagged with a role. The system sets the scene, the user asks a question, and the assistant provides the perfect answer. It's basically a script for a flawless conversation. Okay, so we know what good data looks like. Awesome. But how in the world do we get there? Let's move to the real heart of this explainer, the quality control pipeline. I want you to think of this as an assembly line, one that transforms messy, raw information into a pristine, high-quality asset that's ready for training. This whole process can really be broken down into 4 key stages. Each one is absolutely essential for building a reliable model. First, we clean the raw data. Then, we annotate it to give it some meaningful structure. After that, we evaluate its quality. And finally, we split it up for effective training and testing. Let's break each of those down. Step 1 is cleaning house, and this part is completely non-negotiable. You have to get rid of anything that could confuse the model or create a risk. That means chucking out broken sentences, sure, but also duplicates. See, too many identical examples can cause the model to overfit, which is basically just a fancy way of saying it memorized the answers instead of actually learning the concepts. And this is critical. We have to scrub all personally identifiable information, or PII, for major privacy and legal reasons. Okay, next up. If your data is just a bunch of raw text, it needs structure. And that's where annotation comes in. This is the process of labeling the data. Maybe tagging text with sentiment, classifying medical reports, or identifying legal clauses. And the good news is there are fantastic industry-standard tools like Label Studio and Prodigy out there to help you do this. Before you go and spend a ton of time and money on training, you have to do a manual quality check. You've got to ask yourself, is the format consistent? Is there enough variety in here? And maybe most importantly, is the correct answer actually correct? Here's a pro tip for you. Just manually reviewing 10 or 20 random samples can save you from that nightmare scenario where you realize your model has perfectly learned the wrong thing. So the final prep step is splitting the data, and this is crucial for knowing if your model is actually smart. Typically, you use about 80% for training. That's the textbook the model studies from.
Another 15% is set aside for validation, which helps you fine-tune things during training. And that last 5%, that's the test set. It's brand new data the model has never ever seen before. It's the final exam to prove it is truly learned, not just memorized.
All right, once you have a clean, structured, and properly split dataset, you are almost there. So let's talk about the final touches, the stuff you need to do to create something that's not just good, but truly enterprise-ready, robust, and safe. A question I get all the time is, so how much data do I actually need? Well, it really depends on the size of your model. This table gives some pretty great rules of thumb. For a smaller 7 billion parameter model, a few thousand examples might do the trick. But if you're working with a massive 70 billion parameter model, you're going to want to be well over 100,000 samples.
Now, getting that much data can be really tough, which is where synthetic data comes into play. You can actually use one AI to generate training data for another AI. It's incredibly fast and scalable. But here's the catch, and it's a big one. It's not perfect. It absolutely must be inspected by a human to check for errors and any hidden biases that might sneak in.
And speaking of safety, this part is just not optional for any serious application. You have to scrub all personal data to comply with major privacy laws like GDPR in Europe. You must filter for toxic language and biases to avoid huge legal and reputational risks. And you need to document where your data came from. Seriously, this isn't just a nice to have, it's essential.
So, let's put it all together. Here's your final checklist. This is what an LMOps-ready dataset really looks like. Is your format consistent? Are your examples balanced and diverse? Have you passed all those critical safety checks and documented your data's license? If you can confidently tick every single one of these boxes, you, my friend, are ready to build.
And that really brings us to the most important takeaway of all. A dataset, it isn't just a folder full of files or text. It is the genetic code. It is the DNA of your model. Everything that model becomes, its skills, its personality, its flaws, and its intelligence, all of it is determined by this foundational material.
So as we all build and use these incredible new tools, we have to ask ourselves a really fundamental question, because honestly, the future of AI depends on the answer. Is the DNA we are creating for our models built to be robust, reliable, and responsible? Is it truly built to last?